Alright, so this is my presentation for Lab 1, which is the Charged Tape Lab. So for the introduction, the purpose of this lab was to determine the amount of excess charge on a piece of tape through observing interactions between pieces of tape. So in order to do so, we had to charge the two pieces of tape, observe their interaction, and approximate the electric force between the two. And then we can use that to calculate the ratio of deficient or excess electrons to the total amount of electrons on the piece of tape. And the main law we're dealing with here is Coulomb's law, which relates the force, the electric force, to the charges on the pieces of tape and the distance between them. So initial observations, we observed that the tapes repel one another, and that the U-tape is attracted to the negatively charged pen, which shows that the charge of the tape is positive, meaning there's an electron deficiency. And then using the floating tape experiment, we can determine the distance where the electric force between the tapes counteracts the gravitational force. So for measurements, the length of tape B was 19.5 centimeters, and then the mass of tape B was found by taking the length of the piece of tape, which was 0.0162 meters, and multiplying it by the mass per meter, which is 0.001 kilograms per meter, and we get 1.62 e to negative 5 kilograms. And then we measure the distance between the tapes right when the tape B starts to float, and that comes out to 1.60 centimeters. And then we can use the mass and acceleration due to gravity to find the magnitude of the gravitational force, which comes out to be 1.911 e to the negative 3 newtons. And when the tape is floating, the electrical force and the gravitational forces on tape B are equal, so this gravitational force will be equal to the electrical force. And moving on to the coding, so I'm just going to walk through the program that I used to simulate the 2-point charges. So first up, we have the constants, so we have our K, 9E9, and then we have the mass of tape B, which is just 0.195, the length times the mass per meter. So those are our constants, and then we create our objects, the individual point charges, which we just make as spheres, and the distance between them is determined by the distance that we measured. And then the radius is just arbitrary, and they're just red and blue. And then for calculations, we calculate our R, which is just the distance between the tapes, the force of gravity, just the mass of B times 9.8 meters per second squared. And then also the final and most important calculation is the calculation of the charge. So we just rearrange Coulomb's law to solve for one of the individual charges by taking the square root of the force of gravity times the distance squared over K. And that charge comes out to be 7.4649 e to the negative 9 coulombs. And then we create our arrows, our vector arrows. So we have the orange arrow to represent the force of gravity, and then we have force, the electric force, which is equal and opposite to the gravitational force. And then final concluding questions. If electrons had a positive charge and protons had a negative charge, you wouldn't actually see any difference between the interactions of the charged objects, as the positive and negative charges would just still attract each other and repel each other in the same way. Like charges will repel, and opposite charges will attract. And in preparing for this lab, it was important to handle the tape as little as possible in order to maintain maximum electron efficiency on the tape and not bring the tape to a neutral state.